Hey guys, Mr. Shaw back again. I'm going to continue with the last couple examples that I had from the last video. So let's get to it. So again, it says there are about 250 mice in your attic. After hiring an exterminator, the population begins to decrease at a rate of 70% per week. How many mice will there be in 2 months? Okay, so the first thing is that you see here, it's the 70% per week. So we need our time in weeks. So two months is going to be 8 weeks. So that's what I'm going to use for t. Alright, so again, it's decreasing, so we're going to use exponential decay. Again, the formula, just as a reminder, a equals a sub 0, the initial amount, times 1 minus r to the t power. Alright, so let's do it. So a equals, initial amount is 250. So 250 mice times 1 minus 70%, so 0.7, I can just leave it as 0.7, all to the t power. And now we're going to go ahead and plug in the 8. So again, it'll be a equals 250 times, again, I'll go ahead and subtract this. So 1 minus 0.7 is going to be 0.3. So 0.3 to the 8th power. So let's go ahead and grab our calculators real fast. So 0.3 to the 8th is 0.006561, so I'm going to go ahead and multiply that by 250 equals. So A equals 0.016. So A equals 0.016. So there is the last mouse is almost dead. All right. So again, that's how far that they'll be decaying. Again, I'm not going to round down to 0. I'm not going to round up to 1. Again, it just said there'd be about 0.016 mice remaining. Okay, so one half-dead mouse. That's a joke. Okay, but anyway, you get the idea. All right, so the next thing we're going to talk about is compound interest, which is going to be kind of the same format. You see, you've got your A value. It's going to be the final amount. The P is the principal amount and the initial amount, and then you're going to do 1 plus the rate divided by the number of periods you're compounding per year. So in this case, like let's say I compounded things monthly, then your N would be 12. Okay, if you did it quarterly, then it would be 4, so on and so forth. Okay, and then this is all to the nt power, so you're going to do, again, multiply that same n, and then t, again, is just the number of years. All right? So, again, we'll get more used to the formula as we go on, but let's go ahead and get into an example. All right, so it says an investment account pays 5.4% annual interest compounded quarterly. Okay, so keep in mind that guy. It says if $5,000 is placed in this account, find the balance after 8 years. Okay, so let's get to it. So the principal that we have is going to be $5,000. All right, the rate is going to be 5.4%. So as a decimal, it'll be 0.054. N is going to be, again, compounded quarterly, so that's going to, N is going to equal 4. And then T, again, is going to be 8, so 8 years. All right, so let's go ahead and plug it into our formula. So it'll be A equals 5,000 times 1 plus the rate, which is 0.054, divided by N, which is 4, all to the 4 times 8 power. That's a 4 here. Okay, so we're getting somewhere. So again, in this case, I can do a little simplification. So let's start just with, start with the 0.054 divided by 4. So 0.054 divided by 4 is 0.0135. So that's what this is going to be. So I can go ahead and add 1 to that as well. So again, that's just plus 1. That'll be 1.0135. So let me go ahead and write that. So A equals 5,000 times 1.0135, I believe. Yes, 135. Okay, and then this right here is going to be 4 times 8, so 32 power, to the 32nd power, rather. So now again, remember your PEMDAS. Before you guys get going here, you're going to do 1.0135 to the 32nd power and then multiply by 5,000. So let's do that. So we're going to take this. This will be so to the 32nd power equals 1.535. That seems low. Maybe not. Maybe that's good. Okay, so that seems fine. Okay, so 1.0135 to the 32nd power is going to be 1.535 again, and then now we can just multiply by 5,000. So times 5,000 equals 7,679 let's say 45. So A equals, and I forgot already, 7,679. 7,679.45. All right, is that right? Yes, it is. Okay, so $7,679.45. Okay, again, that'll be your compound interest compounded, or all your interest compounded quarterly using that formula. Okay, let's do one more. All right, so your parents put $10,000, man, wouldn't that be nice, $10,000 into a CD. This stands for Certificate of Deposit, okay? Okay, so again, and that is, again, apparently I cannot spell certificate. Okay, so certificate, got it. Okay, I've had a long day, okay, don't judge me. Okay, so Certificate of Deposit, and again, this is just a method of investment. It's just one of many ways that you can do it. Anyway, so Certificate of Deposit into a CD the day you were born, okay? The account earns 3.5% annual interest compounded monthly, okay, so let's underline that. Okay, and then how much will you have the day you turn 18? All right, so in this case, again, the principal is $10,000. The rate is 3.5%, so 0.035. And then it says it's compounded monthly, so n is going to equal 12. And then the t is going to be, again, the day you're born, they do that, okay? And then it's asking how much you'll have the day you turn 18, so t is going to equal 18 years. Right? I'll just write 18. All right, so now let's go ahead and plug it into our formula. So A equals the principal, so 10,000, times 1 plus the rate, so 0.035 divided by 12, and then to the 12 times 18th power. All right, so let's go ahead and do some cleaning up here. Okay, so this is going to be, and I'll just keep the 10,000. So I can start with the 0.035 divided by 12, so let's do that. So 0.035 divided by 12. Okay, it's this guy right here, and then we're going to go ahead and add 1 to it, save some time. So this will be 1.0029. So let's, and again, I'm not going to round mine. I'm going to keep it like this, and you don't want to round yours yet either. On my equation here, I will round it just because obviously I don't have space for all this. Okay, so I'm just going to do 1.0029. Okay, and this is all going to be, okay, so then we do 12 times 18. So here, hang on. So then we'll do 12 times 18 is 216. So this is going to be to the 216th power. So now we'll go ahead and take this all to the 216th power. So 216. And you get 1.875. And then again, now we just need to multiply that by 10,000. So I'll do that. So times 10,000. And you get $18,758, and let's just round up to 90 cents. Okay, so 18,758. So 18,758.90 cents, and that's going to be the amount you get on your 18th birthday. Must be nice. All right. So again, guys, if you guys have, that's all I got for you today. If you guys have questions, let me know, and we'll take care of it then. See you guys later.